This is Cameron Chai bringing another episode of AZO TV. And today I'm speaking to David Lewis from Nanonics, and he's going to tell us about their Nanonics Multiprobe SPM system.
Thanks, Cameron. What we have here is the latest series in the Multiview system. It is the Nanonics Multiview 4000, which is our multiprobe SPM system. And it's the first commercial AFM which can have up to 4 independent AFM probes working within nanometers of each other. And for us, this is really the culmination of many years of work. Nanonics has always had a very unique platform in developing glass-based probes. And if you see over here, we have an image of our Ensom probe, which was our first glass-based probe. And we have a lot of knowledge and technology how to take a glass probe and to pull it into a normal force AFM probe. And over the years, we've added a lot of different probes to our kit. We have electrical-based probes, where we have a single nanowire. We have a single wire inside a glass probe. We have thermal probes, where we have 2 wires, which act as thermocouples inside the probe. We have probes for chemical delivery. We have probes for scanning electrical chemistry. And so, by having a multi-probe system, we were really able to develop this nano toolkit into a nano workstation. And of course, this system is part of our Multiview series, which means that it is completely open optically, both from above and from below. You can see over here where the probes are, that there's an open optical access where the sample sits. This is our sample scanner. And each one of these towers is a tip scanner. So, as you can see here in the sample scanner is completely open optically, and it gives us, so we can integrate this into an upright microscope or an inverted microscope. And what we see over here is a very faint integration. We see here a very faint picture of our integration with the dual microscope, which is an Nanonics design based on Olympus microscopes, where we have 1 microscope from above and 1 microscope from below. So some of the optical integrations which we've done with this multi-probe system has been integration with Raman, integration with SEM, and you can see this in the background. We've actually introduced multi-probes into a SEM system. This is with the FEI SEM, and we see it scanning, the probe scanning inside the SEM itself, and we're getting a SEM imaging of the probe scanning over here. And so some of the unique experiments which people can do with the system is they're allowing to do, we've had people do thermal conductivity measurements on nanowires, where they have 1 probe heating the nanowire and 1 probe measuring the thermal conductivity at different spaces relative to that probe. We've had people do nanoplasmonics, where they introduce when they introduce light, and they create into a waveguide, and they create a surface plasmon polariton, and they use the other probe to map the propagation of that SPP. And there are many other experiments and different directions which people are taking with the system today. And for us, what's really exciting is we're just starting to see the different directions which people are taking with it, both in terms of papers and in terms of different research directions. And for us, this is very exciting to see really a new evolution and a new direction in the area of SPM.
So Dave, what's the maximum number of AFM heads that people can put into the system?
So with this system, with this configuration, we can bring up to 4 independent probes. So each probe works independently. You have AFM feedback, you have AFM scanning. Each one can be removed and used as an independent AFM. Each one has tip and sample scanning, and we can have up to 4 of them working together. One popular area for more than 2 probes is when we do multi-probe electrical measurements. So you have 2 probes creating electrical contacts, and you have a 3rd probe scanning over the area to get electrical conductivity or resistance measurements.
So that's the typical sort of configuration. People have different types of probes on each head?
So you can have usually different types of probes on each head, which are working together to create a measurement. So if you have 2 electrical probes or 3 electrical probes, you're measuring the conductivity or the resistance. If you have 2 optical probes, one is introducing an optical phenomenon, and the other one is mapping that optical phenomenon. Same thing with electrical and thermal probes. Another direction which people are taking is to do SPM measurements where the probe is not super thin, and then you a tip enhanced Raman measurement, where you can have a probe there where the aperture of the probe is quite large, even though the optical resolution is very small. But then you can have an AFM probe where you can get a very high resolution AFM image and you can combine those two images together. So that's another direction where people are taking one type of probe and then a high resolution AFM probe so they can copy those images together. Another direction which is gained a lot of popularity today is to do integrated measurements, where you have a Raman system doing Raman measurements, doing some kind of nano manipulation and seeing how that nano manipulation is affecting, for instance, the Raman measurement. So there's another general integration area.
All right, David, if anyone wants more information about the multiprobe SPM system, or for that matter any of your other systems, they can find that on your website?
Definitely. Our website is www.nanonics.co.il.
All right, David, thanks for taking a few minutes to tell us about the multiprobe SPM system.
Thanks a lot, Cameron.